Hello, so in this video I'm going to be introducing column proofs. We're going to go over a few different theorems, and we're also going to go over how we're supposed to write proofs. Majority of geometry revolves around proving various things by utilizing information given. In a two-column proof, we depict our analytical understanding of the problem by dividing the information into two columns and several rows. Usually, in our first column and first row, we have statements, and in our second column, we have the reasons. The statements are what we are proving, and our reasons are the evidence. So we include theorems, postulates, and definitions in our reason column. Here are some of the basic theorems we're going to discuss in this video. Theorem 1 states that if two angles are right angles, then they're congruent. Theorem 2 states that if two angles are straight angles, then they're congruent. Now, both of these theorems are pretty self-explanatory because if two angles are right angles, that means they both have a measure of 90 degrees, and therefore they both are congruent to each other. Similarly, if two angles are straight angles, then they both have a measure of 180 degrees, and therefore they both are congruent to each other. Theorem 3 states that if angles are supplementary to the same angles, then they're congruent. Now, if we took angle X and angle Y supplementary to angle Z with measure of 150 degrees, we'll be able to calculate the measure of angle X and Y as 30 degrees, and therefore they both are congruent. Theorem 4 states that if angles are supplementary to the congruent angles, then they're congruent. If we take four angles, angle A, angle B, angle C, and angle D, with angle C and D being congruent to each other with a measure of 70 degrees, and we know that angle A is supplementary to angle C and angle B is supplementary to angle D, then we will realize that angle A and angle B are supplementary to angle with measure 70 degrees, and therefore both of their measures is 110 degrees and thus can be concluded to be congruent. Theorem 5 and 6 are similar to 3 and 4, except with the exception of them being complementary angles rather than supplementary. The addition property. We have two major theorems under the addition property. The first theorem states that if a segment is added to two congruent segments, then the sums are congruent. Now, instead of a segment, you could also use an angle, so therefore you could state if an angle is added to two congruent angles, then the sums are congruent. The second type of theorem states that if congruent segments are added to congruent segments, then the sums are congruent. This also can be used with angles. So if congruent angles are added to congruent angles, then the sums are congruent. Now here's an example with the addition property. Here we have a diagram of triangle AEC and triangle DFB that are connected at segment BC. They've given to us that segment AB is congruent to segment CD. They're asking us to prove that segment AC is equal to segment BD. So when writing our column proof, we first have statement, then we have reason. Our given is that segment AB is congruent to segment CD. In the second row, we have that segment AC is congruent to segment BD. The reason for this is because if a segment is added to two congruent segments, then their sums are also congruent. Now, if you think of it, the segment that is added to two congruent segments is BC. So when BC is added to AB, and when BC is added to CD, the sums are congruent to each other. Similar to the addition property, we also have a subtraction property. In the subtraction property, the first theorem states that if a segment or angle is subtracted from congruent segment or angles, then the differences are congruent. The second theorem states that if congruent segments or angles are subtracted from congruent segments or angles, then the differences are congruent. Now we're going to do a proof using the subtraction property. Here we have diagram of triangle NOP with the diagram of triangle ROP drawn inside the triangle NOP. They have given to us that angle NOP is equal to angle NPO and angle ROP is congruent to angle RPO. They have asked us to prove that angle NOR is congruent to angle NPR. In our first statement, we use the given, so that is angle NOP is congruent to angle NPO and angle ROP is congruent to angle RPO. The reason for that is it's given to us. The second statement says that angle NOR is congruent to angle NPR. The reason for this is a subtraction property. If two congruent angles are subtracted from two congruent angles, then their differences are also congruent. So that means if two congruent angles, which are angle ROP and angle RPO, are subtracted from two congruent angles, which are angle NOP and angle NPO, then their differences, which are angle NOR and angle NPR, are congruent to each other. Moving on to the multiplication and division properties. In the multiplication property, it states that if a segment or angle are congruent, then their like multiples are congruent. In the division property, it states that if a segment or angle are congruent, then their like divisions are congruent. Now we're going to do one of the problems using one of these properties. Given are that angle TRY and angle ABE are congruent to each other, ray RW bisects angle TRY, and ray BC bisects angle ABE. They have asked us to prove that angle TRW is congruent to angle CBE. In our first statement, we write all are given, and the reason for that is because it's given to us. In our second statement, we have written that angle TRW is congruent to angle CBE. Now this is because of the division property. It states that if two angles are congruent, then their like divisions, which in this case would be a half, are also congruent. Now we're going to go over three really easy but very important properties. The reflexive property states that for any real number x, x is equal to x. The substitution property states that for any real number x and y, where x is equal to y and y is equal to x. So therefore they can be substituted for each other. The transitive property states that for any real numbers x, y, z, and a, if x is equal to y and y is equal to z, then x is equal to z, or if x is equal to y and y is equal to a, and a is equal to z, then x is equal to z. Now we're going to do a proof using one of the three properties that we just discussed. Here we have a parallel line with a transversal. So given that angle 1 is congruent to angle 3, angle 2 is congruent to angle 3, and angle 2 is congruent to angle 4. They have asked us to prove that angle 1 is equal to angle 4. So our first statement would use all the givens, and the reason would be that it's given. The second statement says that angle 1 is equal to angle 4. Now the reason for this is the transitive property. That is, if angles are congruent to congruent angles, then they're congruent to each other. That is because angle 1 is congruent to angle 3, and angle 4 is congruent to angle 2. And angle 2 and 3 are congruent angles. So because angle 1 and 4 are congruent to congruent angles, they're also congruent to each other.